not every system has a solution. There are cases where there's no solution. And there are some systems that have infinite solutions, which means that no matter what values we substitute in for x and y, every single value will give us two true statements. So, no solution and infinite solutions. The good thing about no solutions and infinite solutions is they're probably the quickest type of systems to solve. Because you're going to notice that something very interesting happens when we solve these, and it makes our job super simple. So the first thing is, we look at this system right here. We have 3x minus 2y equals 18, negative 3x plus 2y equals 27. This system has no solution. But how do we know that? Well, let's examine what happens when we start solving this from left to right. You ask yourself the questions. Do you have, oh, by the way, there's a small typo in your notes. These are x's in your notes, they're supposed to be y's. I've corrected that, okay? So, do we have inverse coefficients in this system, yes or no?
Yes.
Yes. For what variable?
X and Y.
For both of them, x and y. So as we work from left to right, what's going to happen to these x's here, guys?
Cancel out.
They're going to cancel out here. What's going to happen to the y's?
Cancel
They're
out.
going to cancel out. So what is left over here?
Just a zero.
A 0. Nothing's left over there. We need something to represent that emptiness, so a 0. On the right side of the equation, we combine these. 18 and 27 make
35. No,
closer, a little higher, 45. And then you have to ask yourself, does 0 equal 45? Yes or no?
No.
No. So what type of statement is that?
No solution.
No solution. We have 0 equals 45. That is a false statement, and it has no solution. When you end up with a statement that is not true, such as this one, that means that there's no solution. You'll see everything cancels out. And you'll end up, kind of looks like what we had when we solved equations with no solution. If you have a false statement, still means no solution. Yeah, what's up?
Do we put the line through the equal sign like we did in the equation?
Good. 0 does not equal 45. Good job. Okay, so that's no solution. Infinite solutions. If you remember this from equations, for no solution, I get a false statement. What type of statement do I get for infinite solutions? I get a true statement. Let's see what happens here when I solve this. So you ask yourself the same question. Do you have inverse coefficients here, yes or no?
Yes.
For what variables?
X and Y.
X's and y. So as we work from left to right, let's see what happens here. What happens to the x's?
Cancel out.
They cancel. What happens to the y's?
Cancel
They
out.
cancel. What happens to the constants?
Cancel out.
They also cancel. So, but we need something to indicate all this cancellation, all this emptiness. What number would go here, class? 0. What number would go here?
Zero.
Equals 0. Does 0
Yes,
equal
sir.
0? Yes, it does. That is a true statement. That system has infinite solutions. So, if you solve it and you end up with a false statement, that's no solution. If you solve it, all the variables cancel out, you end up with a true statement, that is infinite solutions. These are not difficult. I think these are actually easier than some of the other systems we solved. However, not all of them are written nice and neat like this. Sometimes you will have to go in and multiply one of the equations before everything will cancel out. You're still asking yourself those questions. Do I have inverse coefficients? Do I have same terms? Do I have evenly divisible? So on and so forth. But if you get to this point with a false statement, that's no solution. True statement, infinite. So let's try a couple of these. This one is still pretty straightforward. We're going to go through it and we want to solve this. Ms. Prats, we draw our line, and then you ask yourself the first question. Do you have inverse coefficients, yes or no?
Yeah.
Yes. For what variable?
X and Y.
X and y. So as we work from left to right, what happens to these two terms?
They cross out.
They cross out, they cancel. What happens to the y's?
They cancel.
They cancel. What number indicates this emptiness?
0.
0. 0, we bring down the equal sign. And then what happens to the constants here?
They also cancel out.
They also cancel out. What number indicates that emptiness?
0.
0 equals 0. And just Ms. Prats, what type of statement is that? Well, yes, but what type of statement?
Oh, true.
It's a true statement. I'll shorten statement to ST and NT. It's a true statement, and that means it has what type of solution?
Infinite.
Infinite solution. Okay, so that one was still pretty straightforward, still pretty easy. Mr. Jackson,
Oh, okay.
well,
I have a question.
you got a question? Okay, what's your question, buddy?
So if it was a true, if it was a true statement, could it have one solution or no?
If it has one solution, it has one solution. Remember, there's 3 different types of solutions for equations and systems. There's one solution, which is what you've been seeing so far. That's that coordinate pair.
Oh.
That's one solution. No solution is when you end up with what we saw right here. Notice this is not a coordinate pair. There's no way to solve this. Here, for this one, infinite solutions, which means that any coordinate pair you substitute in here will solve it. It'll give you 2 true statements. If you substitute in 0, 0, 1, 1, 2, 2, 5, 7, whatever, you'll get 2 true statements. So it doesn't matter. Any coordinate pair would solve this system. Okay? And when we get to graphing these, you'll understand why any coordinate pair will solve this. Because we can graph these lines. And if we do graph these lines, you'll realize that what you're graphing here is one line, and the other line falls right on top of it. If you have both lines together, that means no matter what coordinate pair you pick, each one of them solves that system. When we get to graphing, that'll make a little more sense. Okay? Question?
Can I answer the next one?
Mr. Jackson is actually going to help me answer that one. That's why I called him.
Yay.
Thank you for volunteering. All right, so once again, you got to ask yourself the questions. We got one more system here. So you go through it and you ask yourself, do you have right now inverse coefficients, yes or no?
No.
No, you do not. Do you have same term coefficients, yes or no? No, you do not. Then Mr. Jackson, do you have evenly divisible coefficients, yes or no?
Yes.
Yes. For which variable?
X and Y.
X and Y. So you can pick your angle of attack. Do you want to go after the X's or the Y's?
X.
We're going to go after the X's. Okay. So we look for the one that has the lower absolute value. Which one of these has the lower absolute value?
2.
2.
Negative
So,
2, sorry.
negative 2. Okay. Lower absolute value. So if this is a positive 4, this is the one I'm going to multiply. I need this to be what?
Positive 4 or negative 4?
Negative 4, the inverse of the positive 4. So the question is, what can I multiply this top equation by to make it a negative 4x?
By positive 2.
By positive 2. So we're going to multiply this by positive 2. I draw my line, and I start multiplying carefully. So I'm going to multiply, and I will get, for the top equation, negative 4x plus 6y equals 36. I bring down the bottom equation, and I have 4x minus 6y is equal to negative 24. So now that I've done that, I should have my inverse coefficients. That's why we multiplied one of the systems. You're welcome. Catherine, let's work from left to right, kiddo. When we work from left to right, in case you didn't know this, blue and red make purple. That's why I'm using purple. What happens to these x terms?
They cancel out.
Gone! What happens to these?
They cancel out.
Boom! They're gone. What number represents this emptiness?
0.
0.
And that becomes 12.
And that becomes 12. Catherine, does 0 equal 12? No, 0 does not equal 12. That is a false statement. And if we have a false statement, Catherine, what type of solution is that? No solution, baby. That's what I'm talking about. Any questions on this? Any questions? No questions. All right.